Now that we've faced off the top of the part, the next thing I want to do is I want to create a pocket that goes through the part. And so this pocket, we actually want it to not just go through the part, but we want it to go all the way through the stock material. And I'll show you how to do that. The pocket that we have here that goes through the part is this one in the upper left-hand quadrant. What we're going to do is we're going to go ahead and select this face. And so when we're in our sub-element and highlight mode here, it asks us again, is this the surface you want? So that is the surface that I want. But what I want to do is I want to hold down the Shift key while I left-click, and then it will select all of the similar surfaces that are adjacent to that. So what it's done now is it's selected all of the surfaces that define the edges of that pocket. If I go over here to my Create Features toolbar, I can go ahead and select the pocket icon right here, and it will create this pocket chain features, what it really is. And what it is a way for Esprit to identify that we intend for this to be a pocket. So it looks like a pocket to us in this orientation. We've now told Esprit that yes, indeed, we want that to be a pocket. And so when we have our pocket here, it actually, if we go to our parameters view here in machining, we can see that we want to cut on the left side of the pocket. And so if you look here, there's an arrow that goes around here. And so that arrow is going around the workpiece, or the edge of the pocket. So it's telling us we want to keep the tool on the left side of the pocket. And if we're doing just a contour in there, if we're doing a climb milling operation, then if the tool's spinning clockwise and we're offset on the left side inside a pocket, it's going to climb around that edge. So I kind of like that. We're going to remove material inside. It says the depth is 0.25 inches, and that's because the distance from here to here is 0.25 inches. It says the draft angle is 0, which means if we had created a solid model that had a draft angle, Esprit would detect it right here with this. We're working the XYZ work plane. All these things, we like this. All right, so we can create our pocketing operation simply by selecting that pocket. We'll go to our solid mill traditional toolbar. We'll come over here to the pocketing icon, and we'll select that. Now, just like with our facing operation, you have to tell it what tool you're going to use. And so we have to use a tool that can fit inside our pocket. One of the nice things, if we have to use a tool that can fit inside our pocket. And so what we're going to do, we're going to use this 3/8 inch end mill. I'm going to go ahead and drag the properties tab down a little bit so we get some more space up here. So we're going to do, it asks us, do we want to do roughing passes? Do we want to do wall finish? Do we want to do floor finish? Now, since the pocket's going to go all the way through the part, we absolutely don't want to do floor finish. We're actually not going to do the wall finish either. We're going to set that to no. It's typically better to set this to no and then do a contouring operation later to do your floor fin or your wall finish if you want to do that. Just do it in separate operations. It gives you a little bit more control with how you do it. In the strategy tab, there's a bunch of different choices that we can have here. So we can choose, do we want it to start on the outside of the pocket and work towards the center? Do we want it to start in the center of the pocket, work towards the outside? Do we want it to simply go in one direction, starting at one edge of the pocket and go across to the other? We can zigzag like we did with our facing operation. We've got our trochoidal, which is where it will actually take little circular passes to go through the entire pocket, and then profit milling. We're going to leave these things for later in the discussion. What I want to look at here is our concentric out. I'd like the tool to start in the center of the pocket-ish, and then work its way out to the edges of the pocket. So I'm going to select concentric out. This morph move and spiral move, I always like to use the spiral move because what it does is if we don't use the spiral move, it will make a pass around and then it will move over into the workpiece and make a pass around. If we use spiral, it will slowly spiral out, and each width of cut at the end of the spiral will be what we set it to, and it's a little bit more forgiving on the tool. So I'm going to use spiral. Morph just means, do we want it to spiral intelligently? So we're going to say yes on morph, yes on spiral. We can ignore the tolerances here, the extra moves we can ignore about that. Now our full engaged feed rate, we can actually look up on our feed and speed chart. But what this is whenever the entire end mill, here I've got an end mill right here. Whenever the entire end mill is engaged with the workpiece, so if it was feeding through like this and making a slot in the workpiece, that would be when the full engaged feed rate kicks in. And so typically we do 80% for this. So I'm going to set that to 80. Our total depth, now it read this total depth based on the depth from our pocketing operation, remember there. Our incremental depth, because we're using the 3/8 inch end mill, our incremental depth that we're allowed to do is 3/8 of an inch, so that's fine. Starting depth is 0. That starting depth is measured from the top of the chain that you've created. So we're going to go ahead. We like all this. We can have stock automation on or off here. It doesn't really matter because the workpiece is in the center here and we don't need to trim anything. On the pocketing tab, there are no islands that stick up in our features, so we can ignore this. On the rough tab, this is where we get to set the feed and the speed. And so our tool is able to go much faster than this 589 surface feet per minute, but the mini mill that we're going to cut this in is limited with a maximum speed of 6,000 inches a minute. So we're going to go ahead and stick with that. I'm going to say, all right, so 54, 10. These numbers look okay. You can verify these numbers on the feed and speed chart that you downloaded in the last exercise. So make sure that you use the feed and speed chart here. Don't just assume that every time I'm doing this, I've got the correct numbers here. Make sure you look those up. We'll go with our cutting strategy climb. That way, when it is not fully engaged, it will be pulling itself into the workpiece as it goes around there. Stock allowance walls, 0, floors, 0. There's a couple different entry modes that are possible. What we don't want to do ever is plunge. We don't ever want to have that end mill move straight into the workpiece on a downward plunge, because we know at the center of the end mill, the surface speed, the cutting speed is 0, and so it's not intended to cut in that direction, or it doesn't cut well. So we can either do a helix, where it does a spiral on the way down, or a ramp. Just based on the shape of this pocket, I'm going to go with ramp. So ramp along pass. So I like ramp along pass. For these tools, we want a ramp angle of 10 degrees. Minimum width, maximum width. If entry fails, skip. Make sure you select this. If entry fails, skip. And then the only other option there would be plunge. And we never want to plunge if we can avoid it. So exit mode is ramp. That looks fine. Links, clearance, okay. So we'll go ahead and click OK here. And it created us a tool path. If we go ahead and simulate, now before we simulate, let's make sure that we've got collision detection turned on. So collision detection, full. I'm going to go ahead and click OK. We'll simulate the operation here. So it's doing the facing pass now. It's finished with the facing. It should do our pocketing operation. Okay, so it's coming in. That's doing the ramp down into the workpiece. Once it gets down to the depth, it will go ahead and spiral out to the finished dimensions of the workpiece. I can speed that up. All right, so that's done. I'm going to go ahead and turn on our comparison window here. And so it shows that the floor is blue there, but that should go all the way through. Now, at the beginning, I said that I wanted our pocket to actually go all the way through the workpiece, not just through the part. And so we can fix that. If we hit stop here, if we know the thickness of our part, and if I go to the front view, now I happen to know that the thickness of the part is 3/4 of an inch. But if you didn't know that and you hadn't defined that stock material, you could estimate it by simply mousing over the bottom. Oh, I gotta turn stock on. Turn the stock layer on, and simply move the mouse down to this point, and in the lower right-hand corner of the Esprit window, it'll tell you that you're at minus 0.80 inches. So that gives you some indication of where the bottom of the stock material is. There's several ways to know this. I do know that the stock material is 3/4 of an inch thick. We've already removed 50 thousandths, so it should be 0.7 inches thick at this point. What we can do here is go to our pocket definition. In the pocket, in the depth here, we can actually change that to be 0.7, or why don't we just go ahead 0.75. And so what that'll allow us to do is that it will extend the, just click anywhere to get rid of that. It will go ahead and extend the definition of that pocket to go beyond the bottom of the workpiece now. And then if there's any radius on the bottom edge of the tool, we'll be beyond that bottom edge of the tool. Our tool will go all the way through the workpiece now to do this. If I go ahead now, play. Oh, no, I gotta go back. Sorry, I gotta go back to my pocketing operation. In the pocket strategy tab here, where it is total depth here, if I right click and say system default, it updates now to that 0.75. Now I didn't have to change the definition of the chain that defined the pocket. We could have just come in here and we could have typed 0.75, and then that tool would have gone all the way through. But if I click OK, now we see that the tool comes through the workpiece. And we'll see if we turn off the stock in this view that it goes down. It actually has 2 levels where it goes around like that. So now let's go ahead, run our simulation again, make sure that we've got full collision detection turned on, run the simulation. It does the facing operation first, and then it does the pocketing operation, and the pocket goes all the way through. Now the reason we want this pocket to go all the way through is because in a future operation we're going to flip the workpiece upside down and put it back in the machine tool, and we want to use the center of this pocket as our work offset so that we can locate the features on the part after we've flipped it over. Alright, so that is our through pocket.